Hello, welcome back. So this video is on a topic that can be one of the most confusing topics in all of OOP and also has an intimidating name, polymorphism, but it's really not as bad as it sounds. The academic definition can be a bit difficult, but we're just going to focus on practical uses, practical applications of polymorphism. So what's it mean? Well, if we dissect the name polymorphism, poly meaning many, morph meaning shapes or forms, it just comes down to the idea that an object can take on many forms. So I said we're going to focus on how to use it rather than freaking out about the definition. So here are the two most important practical applications of polymorphism. The first is a single method working in a similar way for different classes. So it might look like this, a speak method. So it's defined on multiple different classes, and each of these objects has its own speak method that does a different thing. So it's the same method name, but it's behaving in different ways depending on where it's defined. And we've already seen examples of this, like when we redefined the Dunder method, the representation method earlier in object-oriented programming to define how like a card or a deck should be printed out. Or just in the last video with MRO, we had that one method defined, I think it was called do something, in 4 different places. And then the second type of polymorphism is where the same operation or the same method works for different kinds of objects. So it's able to handle more than one type of object. So something like this, len, the built-in function, it's able to work with a list, a tuple, a string, and it's able to give us a length and work consistently with multiple types of things, right? It's not just one class always, different types, although technically there's a distinction between these built-in types and our own classes, but for this example, it doesn't matter. So let's begin by looking at the first example, polymorphism and inheritance, where we have a method that works in the same way for different classes. And I should point out, it does say class method here. This is not to say class method single word, a decorator compared to an instance method. I just mean a method in a class, which maybe I'll edit this slide. It's a bit confusing now. Okay, anyway, a common implementation of this is to have a method in a base or parent class that is overridden by a subclass. So we've already seen this. We just haven't been using that term, overriding, but here's an example. So there's an animal class that has a speak method. There's a dog class and a cat class. Both inherit from animal, but they have their own speak method. And if you look at what the animal speak method says or does, it's just an error. It raises an error that says not implemented error. So this is actually a built-in error that we can use, that we get, that's used for exactly this type of situation. When we want to define a class and basically enforce that whatever the name of the method is, speak, should be implemented on anything that inherits from animal. So if we make an instance of dog, we call speak, it's going to return woof. We make an instance of cat, we return speak, or we call speak, it should return meow. But if we made a new class and we didn't return speak, but it inherited from animal, we would get an error. So I have this example here. So if I did something like class fish inherits from animal, I don't know why I have an extra C up there. And if I just put a pass in here, otherwise I'll get an error. If I try and do, well, first I'll do dog. If I do d.speak, let me print that. Okay. And then let's do f equals a new fish. And then I call f.speak. So there is no speak defined on fish, but there is one defined on animal. So let's run this. We get woof, which is first, and then we get this not implemented error. Subclass needs to implement this method. So this is an example of polymorphism, where this one method speak is implemented both on a child and a parent class. It just happens that the way it's set up here, this is a common pattern, like I said, where suppose we're working with a team, or you're building a class that other people are going to then write their own sub or child classes with. It's not uncommon that you would do something like this, basically as a direction to tell people, hey, you need to define your own version of this method in any child class. But don't get too caught up in that. The point is that we're using the same method name to do different things depending on which class called it. Same method name, all 3 places, just depends on who's calling it. All right, so that's one example of polymorphism. The second type of polymorphism is having the same operation work with different types of objects. So we've been working with this since the very first section of this course, adding two numbers together. We have an int, and we get 10. If we had a string and a string and there's a plus sign, it works totally different, right? We get 82. Concatenation. If I had an int and a float, we also get a different result than just two ints. So one method behaves differently depending on the objects that it's behaving on or with. And the way it does this, by the way, is with special methods, dunder methods. We've actually seen some of them in practice. And in the next video, I'm going to dive into, it's going to be pretty fun, I think. Hopefully I'm not selling it too much, but it should be fun. And we'll define our own class and put a bunch of these special magic methods in that give instructions to Python for how to deal with our objects, so that we can define things like the length or the string representation, but also we can define how an object or class should be multiplied or added, and we'll create our own plus sign, but for a human class, for example. So that's in the next video. For now, let's just wrap up polymorphism. So we saw that it really just means a single object taking on multiple forms. And what that really means, there's two different definitions or two use cases. Having one method work multiple ways, depending on the class that it's written in. And then having the same method work in different ways, depending on the kind of objects that it's working with. Okay, next up, we are going to implement our own version of this second example. Should be fun.